Bismillahirrahmanirrahim. Aromaticity. Now, first of all, we shall explain the conditions of aromaticity. An aromatic molecule must be cyclic or in the ring form. This cyclic form must be planar or flat. Number of pi electrons in the ring must obey Huckel rules of 4n plus 2 pi electrons. The pi electrons must be in conjugation. So these are the conditions which an aromatic molecule should fulfill. Now, contrary to the aromatic compound or the aromaticity, there is anti-aromaticity, which follows 4n pi electrons rule. Although the molecule would be planar, would be cyclic, and the pi electrons would be conjugated. But due to the 4n pi electrons, there would be no aromaticity, and we shall observe anti-aromaticity. Now, in case of non-aromatic compounds, in any organic molecule which is devoid of any one of the conditions or the criteria of the aromaticity, which has been mentioned earlier, that compound or that molecule would be non-aromatic. Now, here we shall discuss some examples of the aromatic compounds or the compounds which are exhibiting the aromaticity. First of all, we can see the example of benzene. Here, this is the structure of the molecule of the benzene. The molecule is cyclic and also it is planar or flat in nature. These are the pi electrons, and the total number of the pi electrons are 6. So it obeys 4n plus 2 pi electron rule, which is the Huckel rule. So in this Huckel rule, the n is any integer which is non-negative, and this start from 0, 1, 2, 3, and so on. Similarly, we can see the molecule of the pyridine. It is cyclic. The structure or the shape is planar and flat. Having the conjugated system of the pi electrons, you can see this is pi electron, then single bond, double bond with pi electron, single bond, then double bond with the pi electron, then single bond. So the system is conjugated. In this system, we can see the molecule is flat or planar and cyclic, also obeying the Huckel rule. So the molecule of the pyridine is aromatic. You can see the example of furan. In case of furan, we have one pair of electron on the oxygen. So also obey Huckel rule. The molecule is planar, cyclic, and there is conjugation between pi bond and then lone pair of the electron, so showing the aromaticity. Similarly, in case of thiophene, we have two electrons or pair of electron, which is in conjugation with this pi bond. So this pair of electron is here on sulfur, and then we have single bond, then we have double bond, then single, then double bond, then single, then the lone pair of electron. So conjugation is present. The molecule is in the ring form. So it is aromatic. You can see the example of pyrrole here, like thiophene and furan. Similarly, in case of cyclopropynyl cation, here we have the positive carbon, which is in conjugation with the pi bond. So pi bond, single bond. Now the carbon which is deficient or positive carbon. So this pi bond can shift here and can shift here and so on. This positive can shift here and also here. So we have the resonance. We have the conjugation between pi bond and positive carbon. So also this fulfill the Huckel rule. That is why it is aromatic. See the example of this anion. So here negative charge also resemble to the pi electrons, which are two electron system. So this pi bond is in conjugation with this. This pi bond is in conjugation with this. So there is conjugation and there is this circulation of the electrons on the ring. So the molecule will exhibit the aromaticity. Similarly, you can see in case of condensed rings, there is a naphthalene and the system is conjugated double, single, double, single, double, single, double, single, double, single, double, single, and then double. So the two rings, they are exhibiting aromatic nature. So the naphthalene as a whole would be aromatic in nature because the molecule is flat, molecule is planar, molecule is cyclic, molecule obey Huckel rule. All the pi electron, they are in conjugation. So the naphthalene exhibit aromaticity. Now we will see the examples from the anti-aromatic compounds are the compounds which are exhibiting anti-aromaticity. So here is one example. You can see cyclobutane 1,3-diene. The molecule is flat, is planar, having pi electron system, which are also conjugated. This pi electron is conjugated to this, and this is conjugated to this. You can see pi bond, single bond, pi bond, single bond. So the system having the conjugation. But this does not obey the Huckel rule. It is obeying the rule of the anti-aromaticity that it contains 4n. pi electrons in the system. So this molecule of cyclobutadiene is antiaromatic. Similarly, see here the anion at this carbon, we have the pair of electron, which is in conjugation with this pi electron, although the molecule is cyclic, although the molecule is planar, having the conjugation, but according to the rule, it obeys 4n pi electron rule. That is, it contains 4 electrons or 2 pi electron pair system. So this is antiaromatic. Similarly, see here, the molecule is flat. We can shift pi electron here. We can shift the pi electron here. There would be resonance. The molecule is also cyclic, but it is not obeying Huckel rule, but it is obeying the 4n pi electron rule. That is, it contains 4 electron system, mean 2 pi electrons. So this molecule is antiaromatic. Similarly, see here, this nitrogen contains pair of electron in conjugation with this pi electron. So this molecule is also antiaromatic. See here, this molecule, this is also antiaromatic according to the rule of 4n pi electron. This pentylene is also antiaromatic system regarding 4n pi electron rule. You can see here 1, 2, 3, 4. 4 pi bonds, which represent 4n pi electron rule. So it is antiaromatic, although the 2 giant rings are planar and all 4 pi electrons or the pi bonds, they are in conjugation with each other, but this is antiaromatic system. Here also, this kind of the system would be antiaromatic with respect to 4n pi electron system. Now we come to the examples for non-aromatic compounds. You can see here, this is cyclic compound, but also planar, but it does not obey Huckel rule. The pi electron system, they are also not in conjugation with each other. You can see here the pi bond, single bond, then again single bond, then pi bond, from here single bond, again single bond. So in between this pi bond and this pi bond, we have 2 single bond. So the system is not conjugated. Here is also the case like that one. So this and this system, they are non-aromatic system or the non-aromatic molecule. Similarly, see here, this is the compound which is open, not cyclic. So does not fulfill the condition of the aromaticity. So non-aromatic. Here we can see the system is not conjugated, although having 6 pi electron system or 3 double bond, but the system is non-conjugated. This pi bond, then single bond, then again single bond, so non-conjugated. That is why it is non-aromatic. See here, pi bond, single bond, pi bond, single bond, then again single bond. So this molecule is non-conjugated. This molecule also non-conjugated because pi bond, single bond, O plus, single bond, non-conjugated system. So non-aromatic. See here, this 8-member ring system, cyclic, but here the pi electrons, they are 4 in number, so they are not obeying the Huckel rule. So this is also non-aromatic system because of its nature of the molecule. So this was all about the aromaticity. We saw some examples here, but in the nutshell, an aromatic compounds is that compound or molecule which is cyclic, which is planar, and which has conjugated system obeying Huckel rule. Thanks.